good morning to all. So now we discuss software project management. The first unit is the conventional software management. Okay, so what is meant by software project management? So it refers to the branch of the project management dedicated to planning, scheduling, resource allocation, execution, tracking and delivery of software and web projects. Then it is called as the software project management. So why we go for the software project management is it is an essential part of software organization to deliver a product keeping the cost within the client's budget constraint and deliver to the project is a per schedule. Okay, therefore the software project management is an essential to the incorporate user requirements along with budget and time constraints. So in that way we can go for the software project management. So what is the project management? It refers to the branch of project management dedicated to the planning, scheduling, resource allocation and execution, tracking and delivery to the software and web projects. So now we go for the conventional software project management. See, what is mean conventional? See, in conventional software management, practices are sound in theory, but practices is still tied to that is outdated technology and techniques. In conventional software, economics provides a benchmark performance for conventional software management principles. See, the best thing of the software is it is the flexibility. So why software is the best thing? That is, it will be flexibility, that is it can be programmed to do almost anything. That is, we can do anything in the programmable. And the worst thing about is also flexibility. The best thing is also flexibility and the worst thing is also flexibility. Why the best thing is flexibility means we can do almost anything, and why it is the worst thing is almost anything, that is the characteristic has made it difficult to planning, monitors and control software development. So this is the worst thing. So there are the two principles. The first one is the best thing and second one is the worst thing. So best thing is the flexibility because of we can do anything, and worst thing is the flexibility, that is it is difficult to monitoring, planning and control the software development process. Okay. See, there are three important analyses of the state of the software engineering industry. The first one is software development is still highly unpredictable. Only about 10% of software projects are delivered successfully within initial budget and schedule estimates. So what we say, only 10% of the software projects are initially successfully, that is initial budget and schedule estimates, so it will be successed. Okay. And second one is the management principle, that is the management discipline is more of a discriminator in success or failure than their technology advances. It is the management discipline is the most important to the successful or failure. It will be depend upon the management. Okay. And third one, the level of software scrap and rework is indicative of an immature process. Okay, that is the level of software scrapping or rework is an indicative of immature process. Okay, so reworking and scrapping is a very difficult. Okay, and all three analyses reached the same general conclusion: the success rate or the software project is very low. So it will be depend upon that the project of the successful rate is low. Okay. Next, waterfall mode. Already we have to study on software engineering, and now we go for the in SPM software project management, the waterfall model. See, the most software engineering text present the waterfall model as the source of the conventional software process. It provides an incitable and concise summary of conventional software management. Here there are three main points are there. The first one is the analysis, coding, second one is the development, deployment, and third one is the testing and deployment. Okay, see here actually the waterfall model is the first one is the requirement analysis, next design, coding, testing, deployment and execution. So these are the waterfall model. Here we have to these part of the things we have to divide in the three parts. See, first one, There are two essential steps common to the development of computer programs. The first one is the analysis and coding. See, this is the analysis. Whenever the analysis will be completed, then we go for the coding. See, analysis and coding both involve creative work that directly contributes to the usefulness of the end of the product. Okay, so analysis and coding both involve creative work that directly contributes to the usefulness of the end of the product. Okay, so that is the analysis and coding. Whenever we have to complete the requirements, then we go for the analysis. So what requirements we have want and what we do something. Okay, that is called as the requirement. Okay, and second one, in order to manage and control all of the intellectual freedom associated with the software development, one of the most introduced several other overhead steps including system requirements definition, software requirement definition, program design and testing. These steps supplement the analysis and coding steps below. Figure illustrate the result project file and the basic steps in develop a larging scales. Okay, so see here, system requirements, software requirements, analysis, program design, coding, testing and operations. Okay, so that is the main thing of the process of the waterfall model. First one is the requirement and next one is the software requirements and third one is the analysis and next one is the program design and next one is the coding and next one is the testing and next one is the operations. This is the process of the waterfall model and we say the large scale system approach. So in order to manage and control all of the intellectual freedom associated with software development, and one must introduce several other overhead steps including system requirements definition, software requirement definition, program design and testing. Okay, these are main things. So system requirements, software requirements and analysis and program design and coding and testing and operations we performed. This is called as the waterfall model. Okay, and this is called as the large scale system approach. Okay, next, the basic framework described in the waterfall model is risky and invites the failures. Whenever you go for the waterfall model, it will be risk and some of the failures will be there. So the testing phase that occur at the end of the development cycle is the first event for which timing, storage, input, output, transfer, etc. are experienced as distinguished from analyzed. So the resulting design changes are likely to be so distributed that software requirements upon which the design is based are likely violated. Either the requirement must be modified or a substantial design change is warranted. And third one is the like one. So first coding, analysis and coding, next one is the framework and third one is the different of testing phases and what are the process will be going, that is the which timing, storage, input output transfers and what are the experience of the different analysis. The resulting design changes are likely to be distribute that the software requirements upon which the design is based are likely violated. See, either the requirement must be modified or substantial design changes is warranted. Okay, next, in this one of 5 necessary improvements for this approach to work, the first one, program design come first, next one is the document design, third one, do it twice, fourth one, plan, control and monitoring testing, and next one is the involve the customer. So program design is the first thing and next one is the document design and next one is the do it twice. So if it is possible to do something before going to the testing, we can do number of times. Okay, and planning, control and monitor and testing is the next one, and second one is fifth one is the involve the customer. So why we say it to involve the customer means whenever the customer is not involved, so whenever the problem will occurred, we can face some of the issues. In that process, we have to introduce to involve the customer what the process is going on. Whenever any problem is occurred, whenever the changes will be there, the customer will be says in that process we have to execute perfectly. Okay, so there are the 5 necessary improvements for this approach to work. The first one is the program design. Come first. The first is the program design cheyali. Next, document to the design. Next, do it twice. So if it's possible, we can do the 1 or 2 times before going to the process. Okay, and next one is the planning, control and monitoring the testing. So how to plan, how to control the particular projects, and how to monitoring the particular testing. So what are the process will be going, what are the process will be done, likewise we have to do it. And next one, involve the customer. So if the customer is involved, it will be better to the any problems will be occurred, we can easily solve that problems. Next, we work for the in practice. See, some projects still practice the conventional software management approaches. See, it is useful to summarize the characteristics of the conventional process as it has typically been applied and which is not necessarily as it was intended. So project destined for trouble frequently exhibit the following symptoms. So some symptoms are useful from that particular systems. See that one. First one, protracted integration and late design breakage, late risk resolution, requirement driven functional decomposition, advisory stack relationships, focus on document and review meetings. These are the main things. Practically we can go for that one. See, first one is the protracted integration and late design breakages. For a typical development project that used a waterfall model management process, before figure the development progress versus time. Progress is defined as the percent coded and that is the demonstrable in straight form. See, the figure will be in that one. See, and the following sequence was common: early success via paper design and through the briefing. So first we go for the paper and commitment to the code late in the life cycle. Next one, integration nightmares, that is unpleasant experiences due to the unforced implementation issues and interface ambiguities. Heavy budget and schedule pressure to get the system working. It will be based on the budget and schedule pressures. Late shoehoming, no optional fixes with no time for redesign. There is no time for the redesign. And very fragile, unmentionable product deliverable late, and what the process will be late going on, and it will be unmentionable. In the unconventional model, the entire system was designed on the paper, the implemented all at once. So once we have to design everything in the paper, then we go for the system. Okay, and then integrated. The below table provides a typical profile of cost expenditures across the spectrum of the software activities. So what is the cost? So how? So in which area we have to using the percent of this cost, we can see for the here. See, in the format, ad hoc text, flowcharts, source code, configuration baseline. See, and that is the activities are requirement analysis, and the product is the documentation, and the flowchart also program design. In flowchart, what is the activities from that? It is the program design we can perform to the particular activity, and the product is the document. And whenever we go for the source code, the activities coding and unit testing. And whenever we go for the product thing, we have the coded units. So what the units will be, we have to testing. And the configuration baseline, that is the protracted integration and testing, and fragile baseline. See, the process will be like that. That is the sequential activities, that is the requirement, design, coding, integration and testing. See, here the development process is the percent of code, and the x-axis is the project schedule. So the schedule will be defined as the like that. Here, whenever the design will be completed, whenever the problem will be occurred in the coding and integration, the process will be like that. That is the late design breakage. So actually target is here, but here whenever the late design breakage is there, the process will be going on like that. Okay, see, design will be completed. Whenever we integration of the all the things, then the problem will be occurred automatically. It will be reduced. Okay, next one we have to go for the increase. So we have to solve the remaining of the problems. Then we go for the integration and testing. So likewise, we have to do that one. Okay, this is called as the progress profile of a conventional software project. Okay, see, format, activity, product, that is the ad hoc text, flowcharts, source code, configuration baseline. See, in activity, requirement analysis and the program design and coding and unit testing and protracted integration and testing. And the product is, in that is the document, and the flowchart is the document. So in the ad hoc text or flowcharts, that is the document. We have to search from the documents. We have to using from the documents. We can implement the particular process and go for the source code. In activity is the coding, to implement the coding and do the unit testing, and go for the product phases. We can use a different type of units of testings. We can perform the particular product. And when go for the configuration baselines, the protracted integration and testing, and next one is the Fragly baseline. See, the process is like that. That is the requirement, next one design, next one coding, next one integration, next testing. Whenever the breakage will become, so it will be up down the particular project. Whenever it will be solved, it automatically go for the increase the process. Okay, so that is the progress profile of a conventional software project. In conventional software project, we can implement completely first of all to the paper, then we go for the to implement the next process. Okay, in here in x-axis we go for the project schedule, and next one from the y-axis we can go for the development progress. So how much of the progress will be done, we can easily see the likewise. Okay, see that one. So in the conventional model, the entire system was designed on the paper, then implemented all at once, then integrated. The below table provided typical profile of cost expenditures across the spectrum of the software activities. This is one of the table of the particular progress profile of a convention of software project. Likewise, whenever it will failed, automatically it will be progress will be reduced. Okay, when we can solve, automatically it will be increase. Okay, and here, so we have to search from the different type of activities. That is a waterfall model, that is the analysis, coding. So first of all, actually we have to learn requirement analysis, like requirement gathering, analysis of the requirement, design, coding, testing and deployment. Okay, these are the process of the waterfall model. Okay, thank you.